Chapter 5 Objectives. Our study goals for this chapter are to use Avogadro's number to determine the number of particles in a given number of moles, determine the molar mass of a substance, and to use molar mass to convert between grams and moles, write a balanced chemical equation from the formulas of the reactants and products for a reaction, determine the number of atoms in the reactants and products, identify a reaction as combination, decomposition, single replacement, double replacement, or combustion. Given a quantity in moles of a reactant or product, use a mole-to-mole factor from the balanced equation to calculate the moles of another substance in the reaction. Given the mass in grams of a substance in a reaction, calculate the mass in grams of another substance in the reaction. Describe exothermic and endothermic reactions. You will notice that as opposed to the first 4 chapters, we are now involved with using our calculator and being able to figure out how much of something there is. So here we go. The first thing that's very imperative to learning about how to figure out how much of your products you're going to get in a chemical reaction is this thing called the mole. Now you may think the mole is like that little furry animal, or that big knot on a witch's chin, or the bad guy that's selling the secrets. But in chemistry, the mole is this unit. It's this quantity. It's this amount. Just like a dozen eggs means 12, and a case of soda usually means 24 cans of soda, and a ream is 500 sheets of paper, and a pair of shoes would be 2 shoes. We have a mole is 6.02 times 10 to the 23rd items. Now that's a really big number. You'll notice how big that number is. Why do we need such a big number? Well, because we're dealing with very small particles like atoms or molecules or ions. And so we have to count with a bigger amount. Now, a mole is this many items. So we could have a mole of cheerleaders, or we could have a mole of cars, or a mole of sumo wrestlers, or a mole of atoms, or a mole of molecules, or a mole of ions. And it is 6.02 times 10 to the 23rd amounts of each of those. But we know that mole of cheerleaders is going to weigh a lot less than that mole of sumo wrestlers. So we need to make sure that we realize that a mole is an amount of items, not the mass of the items. So here's another example. A mole of an element is that many atoms of the element. A mole of carbon is the same amount of atoms of carbon. A mole of sodium is the same amount of the atoms of sodium. Number of particles in 1 mole samples. So notice, it doesn't matter what the mole is, whether it's an element or a compound or an ionic compound that we're going to call in formula units. If we ask how many particles are in 1 mole of these items, that answer is still the same thing, 6.02 times 10 to the 23rd. Now, we can go back and remember how to use dimensional analysis, which is our unit conversion where we're going to be canceling out. So 1 mole is 6.02 times 10 to the 23rd whatevers. We'll call it particles. We could write it as 6.02 times 10 to the 23rd particles over 1 mole, or we could write it as 1 mole over 6.02 times 10 to the 23rd particles, for whatever we need as we're going to convert. So, the guide to calculating atoms or molecules. Number 1, state what's given and what's needed. 2, figure out the plan to convert from moles to atoms or to molecules. Use Avogadro's number, set up the problem, and calculate the number of particles. So how many carbon dioxide molecules are in 0.5 moles of CO2? So state what's needed. Well, and what's given. Well, we need molecules of CO2, and we have 0.5 0.50 moles of CO2. So we're going to use Avogadro's number to convert. We got to figure out which of these conversions we're going to use, because we can use whatever we need to cancel out. So we're going to start with what was given, 0.50 moles of CO2. So we know we're going to have to put our conversion unit so that the moles of CO2 is on the bottom, so that the conversion of moles to CO2 cancel out. So then we have 0.5 times 6.02 times 10 to the 23rd molecules of CO2. Now, please plug that into your calculator, and please do it. And when you do, do not press the multiplying sign. Use whatever button is on your calculator that means the times 10. It could be your 10x, it could be your second EE, but please get this answer. If you don't get this answer when you calculate this, try it again. If you still don't get it, send me an email and I'll show you, and we'll walk through how to use the particular buttons on your particular calculator. So here's another one. The number of atoms in 2 moles of aluminum atoms is, okay, gives us some choices so we know what we're going to set up. We know that we are given 2.0 moles of aluminum. We need atoms of aluminum. There's only one way to get from moles to atoms, and that is to use Avogadro's number. And we know that we can use Avogadro's number with the 6.02 times 10 to the 23rd atoms over 1 mole, or vice versa, 1 mole over 6.02 times 10 to the 23rd atoms. So let's see. We start with what was given, the 2.0 moles. So we know the 2.0 moles of aluminum, we're going to put over 6.02 times 10 to the 23rd aluminum atoms over 1 mole. Why? So the moles of aluminum cancels out, and the only label that remains is atoms. You do the math, and you should get 1.2 times 10 to the 24th. If you don't, shoot me an email. So now then, see if you can do this problem. Here we have the number of moles of sulfur in 1.8 times 10 to the 24th atoms of sulfur is. Gives us some choices. So let's see. We are given 1.8 times 10 to the 24th atoms of sulfur, and they're asking for moles of sulfur. The only way to get from atoms to moles is by using Avogadro's number. We got to just figure out which way we're going to use it. Do we use it like we've used the last two, or are we going to have to think about how we're going to use this one? I'm hoping you caught the hint. We're going to have to think about this. So here we go. We set up with what was given, 1.8 times 10 to the 24th sulfur atoms. Because atoms is on this side of our divided sign. That means that the conversion we're going to need is to have 1 mole of sulfur over 6.02 times 10 to the 23rd sulfur atoms. Now, that means you're going to go 1.8 times 10 to the 24th times 1 divided by 6.02 times 10 to the 23rd. Please do this on your calculator. You should get 3 moles of sulfur. If you get some big number, I know what you're doing wrong on your calculator. But you don't know what you're doing wrong. But I can help you. So if you don't get 3 when you do this, please send me an email and let me help you walk through this.